Good morning, bio kids. I think it would be helpful to have some video instruction for the first time you try to do some Hardy-Weinberg problems. Most of you guys did a great job taking notes on the textbook instructions, or I guess it's the textbook description of the Hardy-Weinberg equation. So I'm going to have some slides here, and I'm going to talk through how to do problem number 1, and then you guys are going to work on problems 2 through 5 and then turn in your work. I'm not grading you guys on your correctness. I'm mostly just grading you on what you're trying to do, so I want to see you try each problem. So here we go with number 1. Before we start with number 1, I want to go ahead and just kind of review the stuff you should have written in your notes. So your notes are open. You have the equation written down, and you can see that the Hardy-Weinberg equation just kind of looks like a quadratic, p squared plus 2pq plus q squared equals 1. It's a good equation, but you're never going to actually have to write it in that form. That's why I was encouraging you to include this section down here that I have the definition of each variable. That's really the key to solving Hardy-Weinberg problems. So you need the definition of the variables down here, the definition of p and q and p squared. That's really key. You're never going to put it into this format up here. The part that you will use, you will need to use this value that p plus q equals 1. That will be a helpful one. So you'll use that in your solving, but you will probably not ever use p squared plus 2pq plus q squared equals 1 in order to solve anything. Okay, so make sure you have your notes out and you have your definitions of each of your variables when we do this. Okay, so in problem number 1, I guess I'll skip back to here's problem number 1. That's what you have in your worksheet there. I always write down my given, so it tells you have a population, and the population has a homozygous recessive genotype. So that's some old vocab from way back in the genetics chapter. We need to remember that homozygous recessive means that both alleles are lowercase. So they tell you right there, homozygous recessive is lowercase a. So that hopefully is a good review for you. And then they tell you that the frequency or the percentage of that genotype is 36%. So as far as the language of 36%, that basically just means that when they say percentage, it's the same thing as frequency. And the other thing I'm hoping you guys are familiar with mathematically is that 36% can be written as 0.36. That's probably going to be more helpful in your calculator when you're doing this, is just to interpret 36% as 0.36. So make sure you're writing that down. Okay, so let's go through and try to answer each of these A, B, C, D, E, and we'll walk through each one. Okay, so it tells you that your given is 36%. So here I have it written as 0.36. So that's just a little easier way to put your calculator. Now you want to look at your list of Hardy-Weinberg variables, and you want to see which one matches up to homozygous recessive. Okay, so it tells you, okay, you're looking through which one is homozygous recessive. Look at all of your Hardy-Weinberg variables, and you're going to find that the Hardy-Weinberg variable that matches up to homozygous recessive is q squared. Okay, so q squared, basically your given is q squared. So they gave you q squared equals 0.36. So that would be a helpful thing to kind of write down as your given. And then when you get to question letter A, it says, what is the frequency of the homozygous recessive genotype? So actually, you don't really have to solve anything for part A. You're just kind of looking at your definitions of Hardy-Weinberg variables, and it helps you to determine or locate that variable. And it turns out that letter A was given to you in the problem. So the frequency of the homozygous recessive genotype is actually 0.36. So that was the part that was given to you in the problem. Okay, let's move on to part B, the frequency of the lowercase a allele. So again, you're going to look at your Hardy-Weinberg variables. So isn't that the recessive allele when you see lowercase a? And when you search through all of your Hardy-Weinberg variables, you're going to find that the recessive allele matches up to the q variable. So just the lowercase q, that is your q. Okay, so since you've already solved for q squared, or you're actually just given q squared in part A, it should make sense that if q squared equals 0.36, then if you take the square root of q squared, you will solve for q. So basically the square root of q squared equals q. So since you know that q squared equals 0.36, that means you can take the square root of that, and you can use your calculator if you need to. Some of you can do that in your head. So the square root of 0.36 is going to be just plain old 0.6. And so what you've done now is you've solved for q. Okay, so now you know q squared equals 0.36, and now you've taken the square root of that, and you know that q equals 0.6. And that's basically solving for the recessive allele. So that's what we've done so far, is the recessive allele now is frequency is 0.6. Okay, moving on to part C. Okay, the frequency of the dominant allele. So again, you want to refer to your Hardy-Weinberg variables, and you want to see which one matches up to the dominant allele. And this one, of course, is just the little p variable. So p is the frequency of the dominant allele, and that's what's being asked here for part C. So this is where you're going to use that fact that p plus q equals 1. That's the one that is going to be helpful for you. So you know that q equals 0.6. You already know that already from parts A and B. And now you're going to plug that into your p plus q equals 1, and you're going to solve for p. Okay, so go ahead and use substitution. Show me the work, like write that down on your paper. And p plus 0.6 equals 1, and of course you're going to find that p equals 0.4. Okay, so 0.4 is the frequency of the dominant allele, because that's what p is. All right. If I'm going fast, just know that you can always pause this video, you can go back, and you can kind of just have time to write things down. You might want to just watch all the way through once and then kind of go back with your paper and your calculator and work through things again. So this is just kind of a quick run through of problem 1. Okay, part D, the frequencies of the genotypes capital A, and capital A, lowercase a. So as far as just remembering what that is, remember this is homozygous dominant, and this one here is going to be heterozygous. So if you look at your Hardy-Weinberg variables, you will see that the homozygous dominant frequency matches up to p squared. Okay, so p squared, that's the variable that is the frequency of the homozygous dominant. Now this is easy because back in part C, you solve for p, and you said p equals 0.4. Okay, so you can use your calculator square function, or you can just, maybe you just know 0.4 times 0.4 equals 0.16, but that is p squared. Okay, so p squared is the frequency of the homozygous dominant genotype. Okay, and then the next one is you're looking to see what is the frequency of the heterozygous genotype matched up to your Hardy-Weinberg variables. And of course, that is the 2pq function. So 2pq, and this is easy because you already know what p is and you already know what q is. So you go ahead and substitute that in. 2 times 0.4 times 0.6, that's going to equal 0.48. So, as far as showing work, you're going to show me that you know that the heterozygous genotype is equal to 2pq, and you'll go ahead and substitute that in and show me that it equals 0.48. Okay, we're already on to letter E. Letter E is asking for phenotypes. Okay, so remember, if you remember what phenotype is, that's how something looks. Now, we don't know anything about the traits in this problem. They're just kind of giving us a general idea of this. So we don't know what the homozygous, the dominant phenotype looks like, but we just know that the only way that you can have a dominant phenotype is if you have either the homozygous dominant genotype, or you can have the heterozygous genotype. Okay, so in order to have this dominant look, okay, so you can have two different possibilities. Whereas if you have the recessive look, or the recessive phenotype, that means the only genotype you could possibly have for that one would be little a, right? So the homozygous recessive is a lot easier because there's only one possibility. Okay, so as far as this top one, it says we've already calculated the frequency. So we already know that the frequency of homozygous dominant is 0.16. We calculated that earlier. And we already know that the frequency of heterozygous is 0.48. So the frequency of either of these happening, so the frequency of having this dominant phenotype, we're going to add these two together. Okay, so this is the homozygous dominant frequency, and this is the heterozygous, the heterozygous, the 2pq frequency. So we add those together and we get 0.64. And then finally down here, when you have the recessive phenotype, that's of course something we've already calculated that was actually given to us in the very beginning of the problem, and that's just good old 0.36. All right, so that's the run through of each of the letters of this problem. There's a lot of steps. Here's the summary in case you would just like to see a summary, but on your paper you should be showing how you got each of those numbers. So, you know, for the first one, you would go back and say, okay, homozygous recessive genotype, that's equal to Q squared, and then you would define that as 0.36. So just make sure you show me some work for each problem. It's okay, again, if you work through 2 through 5 and you don't get all the correct answers, but I just want to see your work, and then I will give you some feedback when you submit that. Please submit it via Google Classroom. All right, good luck, guys.